Greetings, everyone. My name is Armando Morin. I'm from Florida A&M University. I am a PhD student in environmental sciences. My research advisor is the Dr. Ananzi, and today I'll be presenting on an indicator-based tool to estimate water consumption. These are basically the point that I'll be talking about during this presentation. Water is a fundamental resource for all ecological and societal activities, including food production, industrial activities, and recreation, etc. And it can be considered as the backbone of every community development due to all type of services it provides. Unfortunately, global climate change and human activities are interfering with the hydrological cycle and ecological evolution of ecosystem, and that leads to high pressure on Earth freshwater resources. Indeed, water is a renewable resource. However, that does not mean its availability is not unlimited. As the world population is increasing, there is a serious concern about the use and availability of fresh water. And that is why it is important to know how much water we use so that we can come up with the best water management strategies. This research has two specific objectives. The first one is to provide a synthesis of information about water consumption. And the second one is actually to develop an indicator-based tool to estimate water consumption that I call ASSET. The process used in this study consisted basically of three parts. The first one was to conduct a meta-analysis, the second one to develop a definition of water consumption, and finally to create a tool that will help to estimate water consumption. The meta-analysis was done by using the PRISMA framework, and a total of 186 articles were analyzed. And with the information collected from those articles, we were able to come up with a definition of water consumption, then develop the indicator-based tool to estimate water consumption. So now, in our definition of water consumption, as you can see in this figure, we have three different sections. We have one for the characteristic, which is basically the components of our definition. We have the subcomponents, then we have the interpretation. How do we interpret the components and the subcomponents? So in that case, we can come up with either a simple definition or a broad definition. A simple definition will include one or two subcomponents, while a broad definition will have multiple or all of these subcomponents. For example, a simple definition, we can have the use of water. That's simple. However, a broad definition will be a little bit more complicated or more complex, if you want. A broad definition can be synthesized as the portion of water, green, blue, or gray, that is withdrawn, then evaporated, transpired, incorporated into products or crops used to provide a service consumed by humans or animals, or otherwise removed from the immediate water environment, and that is not returned to where it was withdrawn. That would be a complex definition. Now, let's talk about the tool a little bit. The tool has basically 6 steps, and then we're gonna go through all of these steps one by one, from sector identification to estimation, which is the last step. Now, if you would like to estimate water consumption, the first step will be sector identification. According to this tool that I created, you need to know for what sector you want to estimate water consumption for. Is it the agricultural sector? Is it the industrial sector or the domestic sector? That will be actually the first step. You need to identify the sector. Now, for the second step, within the sector, you need to choose what subsector you are targeting. As we said before, let's say you have agricultural, industrial, and domestic sector. If you choose agricultural sector, are you going to go like into animal production, or you're going to do it for crop production? And you can do it for both. So this will be the second step, subsector identification. Now, for the third step, it will be activity identification. Within the subsector that you are targeting, now, which activity you're thinking about? You know, there may be like multiple activities within a subsector. And we're going to keep the same example. Let's say you choose the animal production. So are you going to estimate water consumption for aquaculture, livestock, poultry? Which one are you targeting? Which one are you going to estimate water consumption for? Or you can do it, as I said before, for all of them. So now let's move on to the step 4. Now, the step 4 is actually about variables and data availability. If you are doing the estimation, the water consumption estimation in the agricultural sector, what are the variables that you need? Do you have all the data that you need? What kind of data you need? And where are you going to find those data? So are you looking at agricultural variable? Are you looking at meteorological variable, climate data, hydrological, etc.? All these are variables that you need to look at if you want to estimate water consumption in the agricultural sector. So now for the industrial sector, it can be tricky because the activities can be completely different. For example, if you look at like food processing, for example, it will be completely different from thermoelectric activity. But for the domestic sector, it is a little bit easier. So you can look at like, population, water monthly bill. You can have like, water saving device, things like that, how many people in the household. So those things can actually help you to estimate water consumption in the domestic sector. Now, for the step 5, it's basically about indicator identification. So you need to identify the indicator that you'll be using in your estimation process. So because in order to estimate water consumption, you need an observable and measurable characteristic, and that's what we call the indicator, right? That you're gonna use to estimate water consumption. So are you going to look at water consumption per capita? Are you going to look at direct water consumption? What is your indicator? What is your measurable and observable water consumption element? So, and after we get all these together, now you're ready to estimate water consumption. So you're ready to get to the last step, which is the estimation process. And in order to do the estimation, you may use some of these equations. So I gathered those equation from the articles that I consulted, and I classified them. I categorized them into domestic, industrial, agricultural. So as you can see, the equation that you will pick will be based on which sector that you are targeting and what activity that you estimate water consumption for. So this is a summary of the tool with all the steps from step 1, which is sector identification, to the last step, which is the estimation process. In conclusion, I can say water consumption can be calculated directly as an indicator, or it can also be attributed or substituted to other similar indicators presented as observable and measurable characteristic of water consumption. So this tool, I believe, can be very useful in future works regarding water consumption. And as a matter of fact, I am using this tool right now to estimate water consumption here in Florida. So before I put an end to this presentation, I would like to thank my advisor, my research advisor, Dr. Anansi Swami. And I would like also to thank the USDA NIFA, the ERNATI for providing funding for that research. And of course, I would like to thank my colleagues, Ryan, Ernesta, and Herbert. Thank you very much.